problem is job sequencing with deadlines. This problem can be solved using branch and bound. Even this problem can be solved using greedy method and dynamic programming. But let us learn how it can be solved using branch and bound. But one thing we should remember, that branch and bound is useful for solving minimization problem. It cannot solve maximization. If you know something about job sequencing with deadline, it is a maximization problem. Like profits are given for the jobs and we want the maximum profit. So we have converted the problem. Instead of profit, we are taking penalty here. So penalty means we have to pay, right? We will not gain, but we will lose. So instead of profit, we are calling it as penalty. So now the problem is to select the jobs and finish them within their deadline such that the penalty is minimized. Now if you are minimizing the penalty, means automatically the profit is maximized. So just the name we have changed. Instead of profit, we are calling it as penalty. And one more thing here is, these are the deadlines for each job and these are the times taken by each job. The amount of time taken for completion of the jobs is varying. It is not same 1 unit of time. They are having different times. I will solve it using branch and bound, and the approach of solving is by generating a state space tree. So we'll be generating the nodes, and for each node we'll define two values. We compute two values that are cost and upper bound. Let us see what is upper bound and cost. See, upper bound for each node will be sum of all the penalties except those which are included in the solution. So upper bound is sum of all the penalties except those which are included in a solution, and the cost is sum of all the penalties till the job that you have considered. So cost is sum of all the penalties till the last job that we have considered. If S is the set of jobs that are included in a solution, then the upper bound is sum of the penalties of all those jobs which are not in that set. And the cost is the sum of all those jobs that are not in the set. Their penalties are added, and here we will consider up to the job that we have taken. So let us say kth job, up to kth job. So while solving, I'll explain how these two are calculated. Let us generate a state space tree. This is the first node, and the cost is nothing, 0, and the upper bound is infinity. And here we'll maintain one value, that is upper, and that is also we'll keep it as infinity. Now one by one we'll consider the job. First job, let us say it is included in the solution. First job. If job 1 is included, then what is the cost? If job 1 is included in the cost, then till job 1 you see. So anything we are skipping, nothing we are skipping. So the cost is 0 only. Now when first job is in the solution, remaining jobs penalties, so that is 10 plus 6 plus 3. So penalties 10 plus 6 plus 3 is 19. So this is upper. Now we got one upper value which is less than that infinity. So update this one, 19. Now next job. Job 1 is over. So job 2, third node. What is the cost? See, this means that we are including second job. So first job we are not doing. So what is the penalty of first job? 5. And what is upper? So except second job, we have to take the penalties of all. So this is 5 plus 6 plus 3. 5 plus 6 plus 3 is 14. So this is updated to 14. So if we are getting any new upper value which is smaller than that one, we will change it. Now the next node will consider third job, that is job 3. So here the cost. So it means that we are just taking third job. We are not doing first, second and fourth job. So till third job if you consider, till here only we should consider. So how many jobs we are leaving? That is 5 and 10. So 5 and 10. So that is 15. Now one more thing we learn. See what I was doing, every node I was calculating cost and upper bound, cost and upper bound. If the upper bound is smaller, I was changing that one. But one more thing you also have to do, that is what is the cost now? 15. What is the upper bound? 14. So that upper bound shows that if we are getting some penalty, at most we may be getting 14. but here this cost has increased, exceeded. So kill this node. So this node is killed. Then fifth node. This means only job 4. So when you are doing only job 4, then all 3 jobs we are skipping. So 5, 10 and 6. So this is 5 plus 10 plus 6 and this is 21. Cost is higher than 14. So kill this node. No need of finding upper bound at all. I have only 2 live nodes which are not killed. Let us expand. So this node I will expand. So first job 1 was done. Now job 2. And also I should try job 3 and job 4. So I'll calculate them one by one. 6th, 7th and 8th node. So what is the cost? See, this means that we have included first job also, second job also. So we are at second job, right? So is there anything that we are skipping? No, both the jobs we are doing. So the cost will be 0. And what will be the upper bound? Upper bound is when we are doing first job and second job, remaining is 9. So this is 9. Upper bound is 9. Oh, we got a minimum value that is less than 14. So update it to 9. Then next, cost of this one. So the cost of this one is, this means that first job and third job we are doing, we are not doing second job, that is penalty is 10. So cost is 10. And what is upper? 9. Kill this node. Then cost of this node, J is 4, J1, J4. So J1 and J4, so we are not doing J2 and J3, that is 16. So the cost is 16. Kill this node. That is greater than 9. Now which node we should explore? Second node we have already explored. Let us explore third node. Now third node, this is 9th node. See, this is job 2. So we can do job 3 and job 4. 10th node. Let me calculate the cost. See, the cost of this one is, this says second job and third job. So we are doing second job and third job. Which job we are not doing? First job we are not doing. So the cost will be 5. Is it less than 9? Yes. Then what is upper bound? I will calculate upper bound also. So out of all we are doing second job and third job. Remaining job. So that is first and fourth. So that is 5 plus 3. It is 8. Oh, we got a minimum value. Update it to 8. 10th node, cost. See, this says second job and fourth job we are doing. So we are not doing first job and third job, right? We are on the fourth job now. So this is 11. So this is 5 plus 6, that is 11. And the 11 is greater than 8. So kill this node. Next one which we should explore, this one. So this one, if it is explored, then this is job 3. See here, the problem solving is lengthy. So I am showing you what are the things you should do in steps. Now at this stage I can explain you that you have to consider one more thing while doing all these that we did not do. Now we need it. What is that? Doing job 1 and job 2 as well as job 3. Is it possible or not? Job 1's deadline is 1. Okay, that is in first hour. And job 2's deadline is 3. Okay, it will wait till third hour. Then job 3's deadline is 2. Job 3's deadline is 2. So let us check them. Job 1 deadline is 1. Job 2's deadline is 3. And job 3's deadline is 1. And what are the processing time? 1 plus 2 plus 1. See, if I complete these two together, then the total time taken will be 3. Total time will be taken 3. This job doesn't require 1 hour. It requires 2 hours. So first hour will do this and remaining 2 hours, this job can be done. So there is no time left for doing this job. So it means when you have taken first job and second job, third job cannot be done based on their time, not based on the deadline, based on the time, because this needs 2 hours. So this job cannot be done, so need not generate this node. Next, fourth job. Fourth job also the same case. It also need 1 time, so this cannot be done. Now which is the last live node remaining? This is killed, this is killed, this one. So let us expand this one. So what I can take here, job 2, job 3, job 4. Can we do job 4? Let us check. See, job 2 is done. That needs 2 units of time and deadline is 3. And the job 3, its deadline is 2 and it needs 1 unit of time. So they can finish off in 3 hours. Now, fourth job, it needs one extra time. So this cannot be done. So this is also infeasible, and that's all. This is infeasible. We have finished the entire tree. Then what is the minimum penalty, or what is the minimum cost we got? That is 8 and 5. This is the node. So the cost that we got is 5 and the penalty is got as 8. What are the jobs that we'll be doing? Job 2 and job 3. Job 2 and job 3. So if we complete job 2 and job 3, then the penalties that we will be saving are 10 and 6, that is 16. And how much penalty we have to pay? Job 1 and job 4 are not done, so their penalties are 5 and 3, so that is 8. So the penalty that we'll be paying is 8. So that's how we got the solution.